842 part 2. I hate when I make so many mistakes that I have to stop the video. Obviously, I've been making a lot of mistakes. I've been watching these, but when it gets too much, I have to stop. So 842, we're looking at arcs and sectors. Imagine a circle like a piece of pizza, or as a pizza, I should say, which is honestly my favorite way to imagine a circle anyways. A slice of that pizza, the area, the pizza slice would be a sector. It's what's known as a sector, and the crust of that slice would be known as the arc. So essentially what we're going to do is we're going to say, all right, well, I have this whole pizza, but I only have a chunk of it. I only have the slice of this pizza, so how much of the area do I really have? So sector ties to area. We're going to use the pi r squared because that's the area of a circle, and we're going to multiply that by how much of the pizza we have at a 360 because there's 360 degrees in the circle. This right here is known as theta. It is, I think it's spelled like this, Theta. It's a Greek symbol. I think it's Greek. It might be Egyptian, but I don't know. Anyway, it's essentially an unknown. It's like an X, but we use it a lot of time with circles. I think we actually talked about that when we did trig, maybe? Like when we talked about degrees. Anyway, arc is, again, the outside, so it's like the circumference. We're going to use the the circumference equation, 2 pi r, and again we're going to multiply that by how much of the pizza we have, and so you're going to see that's kind of our goal, and that's kind of what we're going to do in this lesson. We'll do it a few times, and hopefully you will have the hang of it. It's one of those things where when you've done it enough, it's pretty easy, but until you get the hang of it, it's a little bit tricky. So hopefully you guys will do well with this. All right, so one of the things I screwed up last time I did this video is I did not do it, I didn't read the question carefully, which is always the case. I never read questions and it always gets me in trouble, and I never learn. I don't understand what my deal is, but it's how I roll. All right, so if I go here, I'm going to turn all this off. I'm going to go to A. Goalie eats a whole big piece of pizza. It's 20 inches in diameter. If it's 20 inches in diameter, I hope we're all okay that the radius is 10. And it says, what's the area of the pizza that she ate? Well, if I can figure out the area of the whole thing, which is pi r squared, which is 100 pi. So that's the whole pizza, by the way. It says leave your answer in exact form. That's it, leave it in terms of pi. So, well, she ate half of it. So I'm going to say she ate 50 pi. So she ate 50 pi inches squared of pizza. Now it says, what's the length of the crust? And this is the part I missed. Well, she would eat in half the crust, right? So the circumference is 2 pi r. That would be 20 pi. But again, she ate half of it. So she would have eaten, so this is our sector. And our arc is telling me that it's going to be 10 pi inches. Again, sector is squared because it's area. Arc is not squared because it's in one dimension. So at that, I'll try and erase this, and I'm sure that I'm going to end up accidentally erasing my square. It didn't happen this time. Lucky me. All right. So now Sonia chooses a slice of pizza from another pizza. Again, we have a diameter of 16, so we have a radius of 8 because it's half. Her slice has a central angle of 45 degrees. What's the area of her slice? Well, the area of her slice is going to be, again, pi r squared. But this time, we're going to multiply it by 45 out of 360 because we know what we have there. Again, just be aware of a couple things. First of all, we need to do order of operations. So this is going to be 8 squared first. So this will be 64 pi. 8 times 8, 64 pi times 45 over 360. I would say grab a calculator. This is going to end up being 1/8 and it's going to be 8 pi, but most of you probably don't know that. So 64 times 45 is 2880 divided by 360 is going to equal 8 pi like we talked about. 8 pi inches squared. I'll tell you, if you're good at fractions, feel free to the way I did it. If not, grab a calculator. Okay, so that's how much of the area of the sector is gone there. But what about the arc? What about the circumference? So again, it's going to be 2 pi r times 45 over 360. And again, this simplifies to 1/8, so it's going to be 16 pi times essentially 1/8, so it'll be 2 pi. But if you don't know that, grab a calculator, multiply it out. 16 times 45 is going to be 720, divided by 360 is going to be 2 pi. And again, we'll just say inches. We don't need to square that. So we will say the sector ends up being 8 pi inches squared. The arc, and don't confuse the arc with the area, right? This is area, this is arc, is going to be 2 pi inches. So moving along, let's go ahead and go to C. Let's hope I don't screw up. God, I hate this. It drives me nuts. I really like the software I'm using, but man, there's a couple of things that drive me nuts about it, that being one of them. Okay, so let's draw another white square. I guess at this point, who am I kidding? This white square is not going to survive, but maybe it will. Okay, so on C, evening draws to a close. Sonia notices that there is only one slice of Goldie's pizza remaining. She estimates the central angle to be 72 degrees. Again, we're going back to the Goldie's pizza, which had a radius of 10. So area is going to be pi r squared times how much we have, which is 72 over 360. So we're going to get 100 pi times 72 over 360. That's obviously going to be 7,200 pi over 360, which will be, what, 2, so 20 pi inches squared. So on this one, our sector is going to be 20 pi inches squared. And again, if you're not comfortable with that, multiply 100 times 72, divide it by 360, and you'll see that you still get 20 pi. Now, if we want to know the circumference, it's going to be 2 pi r times that 72 over 360. So it's going to be 20 pi times 72 over 360. Again, if we cross cancel there, we get 1/18, and it's going to be 4 pi. But anyway, so 20 times 72 divided by 360 is indeed 4 pi. And again, we're just going to call that inches. So here we're going to say that our arc is 4 pi inches. On to question D, which again, I do not expect this square to survive, and it didn't. It seems like the messier it is, the more likely it is to survive, but even then I was not able to salvage it, which is disappointing. So let's go the right square. I guess I'm erasing it for sure for this one, covering up some of that question. Okay, so on D, a portion of a circle like the crust of a slice is called the arc. This is a set of connected points from a fixed distance. There we go, there's the arc. The length of an arc is part of the circle's circumference. If a circle has a radius of 6, the length of the arc would be 30 degrees. I'm sorry, what is the length? So we have a radius of 6. So again, I'm only asked about arc on this one. So it's going to be 2 pi r times 30 over 360. So I'll get 12 pi times 30 over 360. Hopefully we recognize this is 1/12 and we're just going to get pi, but if we don't, 12 times 30 is 360. 360 divided 360 cancels. So I'm going to get pi centimeters on this one, it appears. And finally, we're going to get to E. So on E, actually probably this one, I'm just going to go ahead and use the black pen. A region that is called the sector. Again, we said that's like the area. So what if it has a 20 degree with a 10 radius? So my area is going to be pi r squared times how much of the 360 we have. So it's going to be 100 pi times 20 over 360. Again, we can grab our calculator here. It's going to be 2,000 pi over 360. 2,000 divided by 360 equals 5.56 pi. I don't know, it's kind of a weird answer, so let's just jump over here real quick before we get too far and make sure I didn't screw that up. Yeah, somehow I screwed that up. So it should be 2,000 divided by 360. So what's my 2,000 divided by 360 is 5.56 pi. Oh, I see what they did. Then that I should have multiplied that. Okay. They have me multiplying that actually by pi. So 5.56 times 3.14. That's where we get the 17.4 something. So we were doing fine. Should have trusted ourselves on that one. All right. So moving along to 889, we are going to say it is useful to be able to calculate the area of a sector for any circle. Work with your team to derive the formula by doing the following tasks. Look at your work from 888 and describe the relationship between the area in the sector and the area of the full circle. So essentially what we're going to say here is if we're going to do the area of a sector, and by the way, they want us to use theta, not x. And like we talked about, we're just going to say, all right, no problem. It is pi r squared times however much of the circle we have at a 360, right? That theta over 360. That looks like a mess, so let's try and clean that up a little bit at least. Theta over 360. And then if we want to do, it says use proportional relationship between the area of a sector and the area of a full circle to write the generalized formula. Oh, I guess I did that already. Area of a sector. Use a proportional relationship between the area of a sector and the area of a full circle to write the generalized formula of the area of a sector in terms of theta and r. Yeah. Okay, so we're done there. We will jump to 890. So let's go ahead and pop this up. And we will jump to 890. So 890 says, use the sectors D and E to answer the following questions. So what is the length of the marked arc for each circle? Leave your answers. So the one that's 3 versus the one that's 5, and we'll leave them in terms of pi. Well, the ones at 3, again, we're going to go ahead and we're going to say that it's the length of the arc that we want, not the sector. So we're going to use circumference 2 pi r, and we're going to multiply that by, we have 30 out of 360, right? So we'll get 6 pi times 30 over 360. We can kind of multiply that. We get 180 pi over 360. So I hope you guys see it's just going to be pi over 2, right? So that one's going to be pi over 2. If we do the one that's 5, we're going to say it is 2 pi r times 30 over 360. We're going to get 10 times 30, so we'll get 300 pi over 360. Hopefully you know we can lop off that there, the zeros, right? I'm just doing some of these as fractions. You can grab your calculator if you want. It looks like 6 is going to go in 5 and 6. So I'm going to get 5 pi over 6. Any questions there? All right, so now it wants us to go back. Oh, I'm sorry. So 5 pi over 6. Okay, so we can get rid of all this and make ourselves have a little bit of space. Now it's saying for circle D, what's the ratio of the arc length? The arc length, which is pi over 2, to the radius. Well, we would divide that by 3. Well, this looks real ugly. We wouldn't divide pi by 2 by 3. So let's go ahead and rewrite that so it looks better. We'll divide 2, and then we'll divide that by 3. But we never divide fractions, so that's the same as saying pi over 2 times 1 over 3. So we end up getting pi over 6. So that's going to be our ratio there. And then for E, it says to do the same thing. What's the ratio of the arc length? So 5 pi over 6 compared to the radius. And our radius is 5. And again, we wouldn't want to write it like a triple stack, so we'll say 5 pi over 6 is the same as dividing by 5 over 1, but we wouldn't want to divide. We never divide fractions. We always multiply reciprocals. So hopefully you can see we get a little cross-canceling there. And lo and behold, it's still pi over 6. So we get that same ratio. So it says, suppose the circle, the radius is 100. Well, my suspicion is we're probably going to get the same thing. So what's the ratio of the arc length? Well, I know that if I do the circumference of the circle, it is going to be 2 pi r times 30 over 360, right? So I'll get 200, and 200 times 30 is going to be 6,000 pi over 360. 6,000 divided by 360 ends up being 16.67, which is not something I'm super excited about working with. So why don't we start simplifying this here. That's going to disappear. And now I have 600 over 36. So 6 is going to go in here 100 times. And it's going to go in here 6 times. I can still divide that by 2. So it's 50 over 3. So it's going to be 50 pi over 3. And we're going to divide that by the radius of 100. So we're going to go down here. 50 pi divided by 3 is divided by 100. Again, we don't like that, so it's going to be 50 pi over 3 times 1 over 100. We can cancel that, and it turns into 2. And holy smokes, look at that. We have that same ratio of pi over 6. So the question is, there's other units of measure besides degrees. You're going to learn about this in Integrated 3. This whole problem was a setup for Integrated 3, which is kind of a bummer, but it's going to introduce us to radians. So when you get to Integrated 3 and you talk about radians, there's a 0.0% chance you'll remember this conversation, but who knows, maybe. So maybe we'll remember this. So a radian essentially is 30 degrees of a circle. It's 1/6 of a circle. And the question would be, why is 30 degrees always end up equal 1/6? Well, think about it. We're going to say 2 pi r, right? That's our circumference of any circle. And then we're going to multiply that by 30 over 360. Well, if I'm going to do that, a couple things going on. 2 times 30 is 60, so I'm going to get 60 pi r over 360. Well, this is going to turn into 6, so there we go. We get our pi r over 6. So that's kind of the deal there, and that's why we're dealing with that. All right, moving along here. We're on 891. So we are going to have Choose Your Pizza Parlor. Choose Your Shape Pizza Parlor sells both circular and square pizzas for lunch. It sells pizza by the slice. The circular has a diameter of 14, so again it has a radius of 7, and is cut into 10 congruent slices. The square, I'm going to go back here real quick. I'm at 890, I'm sorry. I just want to verify here. 2 pi r, why do I have a r and they don't? For some reason I have an extra r. We have the pi over 6, but they're not multiplying by the ratio. They're just doing it by the pi. Okay, so when they introduce the ratio, when they introduce the radius, they'll multiply that by the r. Okay, so back to this one. We have this radius of 7, and we have a 1 foot by 1 foot. So this is 12 inches by 12 inches, right? Obviously, cut into 8 slices. So the slice of a circular pizza costs $2. What is a fair price for a price of a square pizza? Well, we need to kind of compare here. So this is going to be 3, 6, 9, 12. This is 3 by 6, so this is 18 square inches, right? 18 inches square. Well, what is this one? Well, we can calculate the sector here because we know the area is going to be pi r squared. And we're going to end up with 49 pi for the whole pizza. But it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. It's 1/10 of it, right? So it's actually going to be 4.9 pi. So if I multiply 4.9 by pi, you can see I have 15.39 inches squared. So we're saying if it's worth 15.39 inches squared is worth $2, how much is 18 inches squared worth? Well, I can cross multiply and get 15.39x equals 36. I'll divide by 15.39, and x is going to equal 36 divided by 15.39, and I'm going to get 2.34. So if we're going to be consistent in our pricing, this should cost $2.34 if this costs $2. And again, if you kind of compare that, if they were both charging $2, you should take the square pizza every time, even though it's the wrong shape. It's more pizza. All right, so Tanya loves pizza crust. Which shape should she order? All right, well, this one obviously has 12, 24, 36, 48 inches of crust for the square. What about the circle? Well, we know it's 2 pi r, right? So it's 14 pi, and 14 times pi is going to equal 43.99 inches. So, yeah, I don't know. Well, I'm kind of running out of room there, so let me clear this. It's 43.99 inches. Or 44. The square is 48. So she should order the square. If she likes crust, she's going to get more crust. Is there a way to cut the pizza, square pizza, into 8 slices that would keep the areas of the slices the same but make the crust more equitable? Is there a way to cut the square pizza into 8 slices? Yeah. You could do something more like this, right? So if you cut it like that, it'd be 1, 2, 3, 4, 5, 6, 7, 8 slices, and you're getting more pizza there each. All right, this felt like a long video. Hope you stuck with it, or at least fast forwarded the parts you needed to see. Have a good one.